Something strange is happening with interstellar Comet 3I Atlas, something that defies the fundamental physics we've understood for centuries. As this cosmic visitor made its closest approach to Earth on December 19, 2025, at a distance of 268 million kilometers, astronomers discovered that it's doing something impossible. Its tail is pointing the wrong way, not just slightly wrong, completely wrong. The tail is pointing directly toward the sun, the exact opposite direction of where every comet tail in history has pointed. And nobody at NASA's official press conference on November 19, 2025, mentioned this mystery. Nobody acknowledged that we're witnessing something we cannot explain. Welcome to the Cosmos Quest. On December 13, 2025, astronomer Tirasak Thaluang captured an image of 3I Atlas using a modest telescope in Rayong, Thailand. When the image was processed through specialized filters that highlight subtle brightness variations, something extraordinary appeared. A prominent feature extending from the comet, not away from the sun, as comet tails always do, but directly toward it. This wasn't the first observation of this bizarre behavior. The Hubble Space Telescope had captured the same phenomenon back on July 21, 2025, when 3I Atlas was still approaching the sun from nearly 3 times Earth's distance from the sun. Then again, on November 30th, after the comet had passed the sun and was heading back out, Hubble saw it again. And it's still there. The latest images from December 15th show this sunward jet extending for approximately 500,000 kilometers, longer than the distance from Earth to the Moon. This is not a temporary illusion. This is not a trick of perspective. This is a real physical jet of material flowing toward the sun, and it violates everything we know about how comets should behave. Let me explain why this is so profoundly strange. When a comet approaches the sun, solar heat vaporizes ice on its surface. Water, carbon dioxide, and other frozen materials turn directly from solid to gas. These gases escape from the comet's surface, carrying dust particles with them. This creates the comet's distinctive coma, the glowing cloud surrounding the nucleus and its tail. But here's the crucial part. The sun doesn't just heat comets, it also pushes them. Solar radiation combined with the solar wind creates an outward force. This force pushes gas and dust away from the sun, creating the iconic comet tail that always and always points away from the sun. This isn't a suggestion. This is fundamental physics. Solar radiation pressure and solar wind are powerful forces. They overwhelm any other motion. That's why comet tails can stretch for millions of kilometers in the direction opposite the sun. That's why we see them at all. Yet 3I Atlas has a jet pointing directly toward the sun. Not just a little bit toward the sun, directly, precisely, tightly collimated, meaning it remains narrow and focused rather than spreading out. The probability of this happening by random chance? According to Harvard physicist Avi Loeb's calculations, 0.000025. That's 25 in a million. Or to put it another way, this should happen in 1 out of every 40,000 comets we observe. It gets stranger. Recent observations have revealed that 3I Atlas rotates with a period of about 7.74 hours. As it spins, the anti-tail jet wobbles slightly, precessing in a small cone. This wobble allowed astronomers to determine something remarkable. The rotation axis of the comet is aligned to within 8 degrees of the direction pointing toward the sun. It's like the comet is essentially spinning like a rifle bullet, with its axis of rotation aimed almost perfectly at the sun. And the jet is coming from near one of the rotational poles. Before perihelion, the jet came from the sun-facing hemisphere. After perihelion, as the comet moves away, the jet appears to come from the opposite pole, which is now facing the sun. For both of these independent regions near opposite poles to produce identically tightly collimated jets pointing sunward is extraordinarily unlikely for a natural comet. The jet maintains its narrow width, only about 6 to 8 degrees opening angle. It's 10 times longer than it is wide. Even after passing perihelion and being deflected by the sun's gravity, the jet reoriented itself to continue pointing sunward. So, what could explain this impossible behavior? Scientists have proposed several theories, though none are entirely satisfying. The first explanation involves ice particles. Dr. Avi Loeb and Dr. Eric Quito published peer-reviewed papers suggesting that the anti-tail might be caused by tiny ice fragments shed from the sun-facing side of the comet. These fragments scatter sunlight, creating a visible glow. Because they're so small, they evaporate quickly before solar radiation pressure can push them backward into a normal tail. But this explanation has problems. Why would these ice fragments remain so tightly collimated over such vast distances? Why wouldn't they spread out? Why would they continue to point precisely at the sun even as the comet tumbles and rotates? Another possibility is that we're seeing a swarm of objects, perhaps trillions of tiny fragments, that were released from 3I Atlas and are now orbiting slightly closer to the sun, always maintaining their position between the comet and the sun. These objects would have to be non-evaporating, meaning they're not typical ice, but something more exotic. Their collective surface area could be enormous, reflecting most of the sunlight we see in the comet's coma. There's also speculation about deep pockets of ice within the comet that sublimate only when exposed to direct sunlight, creating focused jets. But for these pockets to be located near both rotational poles and for both to produce identically collimated sunward jets stretches the bounds of probability. And then there's the hypothesis that makes most scientists uncomfortable. What if 3I Atlas isn't entirely natural? If this were a technological object, a probe or spacecraft from another civilization, a sunward-pointing thruster would make sense. It could be using the sun's gravity as a brake, similar to how our spacecraft use rocket engines to slow down when approaching a planet. The tight collimation would be explained by deliberate engineering rather than chaotic natural processes. Most scientists strongly reject this interpretation. Natural explanations, even highly improbable ones, are preferred over invoking alien technology. But the anti-tail remains unexplained, and the longer it persists, the more questions it raises. Perhaps this phenomenon is more common than we realize, and we simply haven't had the technology to observe it until now. Or perhaps 3I Atlas is truly unique, a one-in-a-million cosmic oddity that defies explanation. 3I Atlas is now receding from Earth, continuing its journey back into interstellar space. Every day it gets dimmer, harder to observe. Is it a natural comet with exotic ice pockets positioned in extraordinarily unlikely configurations? Is it a swarm of non-evaporating fragments? Is it something we haven't even imagined yet? Or could it possibly be something manufactured, deliberately aimed, engineered to do exactly what it's doing. We may never know for certain, but its brief visit reminded us that the universe is stranger than we know. Did you know about the newly discovered quasi-moon, which has been orbiting the Earth for more than 60 years? Watch the next video to know more. And if you like such videos, please consider subscribing to our channel. Until next time, keep looking up and stay curious.